Hello and welcome to Our Amazing Bodies, a science show that will look at all the systems that keep us moving, keep us full of energy, and keep us thinking and feeling. But before that, let's start off with the structure that holds all these systems in place, our skeleton. Now this may sound strange, but you do not actually have the same number of bones in your body throughout your lifetime. When you're born, you have around 270 bones in your body, but as you grow into an adult, some of these bones fuse together until eventually you're left with around 206. Some of these bones have different purposes, with most of them used to support your body and maintain your shape, with others, such as your ribcage and your skull, used to protect your vital organs. The longest bone in your body is the femur, which sits in the upper leg, with the smallest bone called the stapes, which sits in your middle ear. Bones are connected in two different ways, a hinge joint or a ball and socket joint. An example of a hinge joint is your elbow or your knee, which can only move in two directions. Whereas an example of a ball and socket joint is your shoulder, which has full 360-degree movement. The bones of males and females, as well as different races, have very slight differences which can be used to tell them apart. This is why archaeologists, for example, can still identify ancient bones from thousands of years ago. Of course, our bones do not move by themselves. They are surrounded by muscles which control our body's movement. Muscles work in pairs, as they can only pull in one direction. For example, you have your bicep muscle working together with your tricep muscle. When the bicep muscle contracts or shortens, it bends your arm at the elbow. Then, when the tricep muscle contracts, it straightens your arm back out again. Similarly, in your upper leg, when your hamstring contracts, it bends your leg at the knee. Then, when your quadriceps contract, it straightens your leg back out again. Muscles are made up of special cells called muscle fibers. When you exercise, you're constantly snapping some of these fibers as the muscles contract and relax, which is why a day after intense exercise, you tend to feel some muscle soreness. However, with rest, these fibers heal and result in the muscle growing. Therefore, it is important for top athletes to incorporate rest into their training schedules to be able to reach their peak ability. However though, you can still snap too many fibers, which result in a muscle strain, or even tear a muscle completely, which could take 6 months to recover from. Connecting our muscles and bones are ligaments and tendons, which stabilize our skeletons. Tendons connect muscles directly to bone, whereas ligaments connect bones to other bones. So here's a quick challenge for you. What I want you to do is place one of your hands in the air like this and keep it perfectly still. Then, without looking, I want you to slowly bring your other arm over the top of your head and try and touch your middle finger. There we go, got it eventually. If you're able to do that first time, well done. But if you're struggling, let's have another go. Okay, place your hand in the same position. So this time, I want you to wiggle your fingers for 5 seconds. Okay. Then, once again, without looking, try and bring your hand on top of your head and try and touch your middle finger. There you go, got it first time, this time. Now, the reason I could do that is because by wiggling the fingers in my hand, I was able to send a signal from the tip of my finger down a pathway through my arm, across my shoulder, up my neck and into my brain, which is telling my brain that my fingers are roughly this distance away from my head. This pathway is called the central nervous system, which carries information and commands to our muscles and organs through trillions of electrical signals that are sent every second. The key pathway is through the spinal cord, which travels from the skull down to the pelvis and branches off into our arms and legs. At the top of the nervous system is our brain, which is the control center for everything we do. Inside, there are around 83 trillion brain cells called neurons, each connected by 300 trillion strands called synapses. These strands are constantly forming and breaking between the neurons, with the pathways used most often becoming stronger and the pathways used least beginning to disappear. Now, you may have heard the term practice makes perfect when learning an instrument or playing a sport. That is because by repeating a skill again and again, you are reinforcing the connections in your brain to become stronger, quicker and more efficient. So so that when you carry out that skill, it becomes automatic. However, if you stop practicing that skill, then the pathways begin to weaken and it takes longer to carry out. This is why, as you get older, you may find that you cannot do some of the things you were able to do before. Different parts of the brain control different parts of your body. The main section is called the cerebrum, which is split into sections called lobes. These are responsible for problem solving, memory, hearing, and your sight. At the back of the brain is the cerebellum, which controls your movement, balance, and mental functions such as your emotions. The trillions of signals sent from the brain move down the brainstem and into the spinal cord. Some of these signals we can control, such as the movement of our arms and legs. But other signals occur automatically, such as for your heartbeat, breathing, and digestion. We also have an automatic protection system that makes instant decisions for us. For example, if you were to accidentally touch something hot, your body will have moved your arm away to safety before you even realise. If any of these pathways in the central nervous system were to be damaged at any point, such as with a back injury, then it could affect the limbs connected below, potentially limiting the ability to walk or move in general. In recent years, however, scientists have developed special devices that create new artificial pathways around the damaged area, which allow the signals to still reach their destinations. This has allowed some people who have previously been unable to walk to take their first steps in decades. The cardiorespiratory system is the transport system around the body that delivers oxygen and nutrients to our muscles to use as energy. It involves two key organs, our heart and our lungs. The process starts when we breathe in through our mouth and nose. Our breathing is controlled by a muscle that sits just below our lungs called the diaphragm. You can actually feel this muscle move up and down when you breathe. If you place your hands just below your ribcage, like this, and spread your fingers out, and then breathe in, you can feel this muscle move down. This pulls your ribcage out and inflates your lungs, sucking in air. Then, as you breathe out, the muscle moves back up again, squeezes the ribcage and pushes the air back out of your lungs. Occasionally, the diaphragm likes to spasm and jump up suddenly, and this is what causes us to hiccup. It can occur when we eat or drink too quickly, or if we are excited. But ultimately, we still don't know the exact reason why we hiccup. When the air enters the lungs, it goes through a structure called the bronchial tree, which, as its name suggests, is a similar structure to a real tree outside, with a trunk that gradually splits into more and more branches. The trunk of the bronchial tree is called the trachea, or windpipe, which moves down your throat. You can actually feel your own trachea by running a finger along the front of your throat like this, where you'll feel lots of bumps and ridges. These are made of cartilage, which feels a bit like bone but is quite bendy. And this cartilage plays an important role in your breathing. If it wasn't there and you tried to breathe in, the pressure of the air moving through the trachea would close it completely, and you wouldn't be able to breathe. The cartilage therefore keeps your airway open to allow the air to move freely in and out of your lungs. After the trachea, the bronchial tree splits into two main branches called bronchi. One which goes down your left lung, and the other which goes down your right. Your lungs aren't the same size though, as your right lung is slightly bigger than your left. This is to make room for your heart, which sits in between your lungs. Branching off from the two main bronchi are smaller branches called bronchioles, which continue to split into smaller and smaller branches throughout the lungs until they can only be seen through a microscope. At the end of these branches are millions of tiny air sacs called alveoli, which take the oxygen that we have breathed in and move it into our bloodstream. Pumping the blood around our body is the heart. If you hold out a closed fist like this, that is roughly the size of your heart, which sits in the middle of your chest. If you are a grown-up, your heart beats roughly 60 to 100 beats in a minute when at rest, whereas if you are a child, it beats by 80 to 120 times a minute. The reason a child's heart beats more is because it's not fully grown yet, so must work harder to move the blood around the body. Your heart beats thousands of times in a day, and can do so because it is made up of a unique type of muscle called cardiac muscle, which is different to the other muscles in our body, as it is the only one that can keep working without ever getting tired. The heart is split into 4 chambers called atriums and ventricles. The right-hand side chambers push blood into the lungs to collect oxygen before returning to the heart through the left-hand side chambers, which then push this oxygenated blood to the rest of the body. Because of the effort required, the left-hand side of our heart is slightly bigger than the right. The blood travels through 2 main pathways called arteries and veins. Arteries take the oxygenated blood away from the heart to our muscles to use as energy. Then the veins take the blood back towards the heart to then collect more oxygen and repeat the entire cycle. The digestive system is my favourite because it involves food and drink. It is the process that allows us to gain nutrients and energy to keep our bodies healthy. We start by placing food and drink into our mouths, where there are 3 things that allow us to break the food down: our teeth, our tongue, and our saliva. We have 3 different types of teeth. At the front, we have our incisors, which snip up our food into smaller pieces. Then we have our canines, which are designed to grip our food and rip it apart. Finally, we have our molars, which are designed to crush our food and grind it into a paste. Our saliva then sticks the food together into a ball called a bolus, before the tongue moves the food towards the back of our mouth, ready to swallow. The food does not just drop straight into our stomachs though, as it first must pass through our food pipe, called the esophagus. For a long time, we used to think it was gravity that allowed the food to drop into the stomach, but that does not explain why astronauts could eat in space, for example. It is down to a process called peristalsis, which moves like a Mexican wave down the esophagus, squeezing the food down into the stomach. It can take 12 seconds to travel from the top of the esophagus to the bottom. Our stomach is on the left-hand side of our body and sits just underneath our rib cage. It is constantly changing size as we fill it with food and drink. At its maximum, it reaches 2 litres in size, which is equivalent to a large bottle of fizzy juice. So let's show you how the stomach works by going through everything that I ate yesterday. Now, for the purpose of this demonstration, I want you to imagine that this plastic bag is my stomach. So yesterday, I woke up and I had the first meal of the day, our breakfast. And for breakfast, I like to have a nice bowl of cereal. Okay, so let's pour that into our stomach. There we go. And you don't have cereal dry, do you? You also have it with some milk. So let's pour in some milk into our stomach. Lovely. And I like to keep nice and hydrated, so I always like to have a nice glass of orange juice as well for my breakfast. Brilliant. So that is my breakfast in my stomach. And when you get to the middle of the day, it's time for your second meal of the day, our lunch. And for lunch, I like to have something very, very special. It's some thick vegetable soup. Okay, so let's pour some of that into our stomach. There we go. Lovely big chunks at the moment. A bit of a mess eater, I admit that. There we go. A little bit more. I do like to eat lots and lots of soup. Let's make sure I get a lot into my stomach there. Brilliant. This is a very messy eater, right? And with lunch, it's always important to keep hydrated again, so I'll add in another bit of orange juice. Awesome. Then we get to the end of the day. We have our final meal of the day, our dinner. And for dinner, I like to have something very special. I like to have some mashed potato. There you go. So we'll pop that into our stomach. And you don't have potato by itself. You have it with other things. Some people like to have beans, some people like to have sausages. But for me, I like to have it with some tomato sauce. Okay, so let's pour some sauce into our stomach. Okay, there we go. Lovely. So there you go, that is everything that I ate yesterday in my stomach. But the food doesn't just sit there all day, does it? Throughout the day, there are muscles around the stomach that are are slowly squeezing the stomach and mushing all this food together, making it a paste. There's also stomach acid inside as well that helps to break down the food into smaller and smaller pieces. Now, it looks a bit like sick, doesn't it? And this is actually what sick is. When you're unwell, you need to throw it up. It's all the contents of your stomach that go back up out your esophagus and out of your mouth. But when it stays inside the stomach, it has a special name. It's called chyme. And at this point, it's ready to go on to the next step. The next stage in our digestion journey is the intestines, which is where we get our nutrients and vitamins from our food. This process takes time though, and as a result the intestines are surprisingly long. They are split into two, a small intestine and a large intestine. Despite their names, the small intestine is 5 meters in length, whereas the large intestine is only 1.5 meters. The reason the small intestine is called so is because it is thinner, whereas the large intestine is much thicker. The surface of the small intestine is made up of small folds or wrinkles, which are designed to increase the surface area to absorb as many nutrients from our food as possible. The large intestine acts like a big sieve, like this one, where it takes out all the remaining water left in our food. How well the large intestine is working can tell a lot about your health. If it takes out too much or too little water, then that's an indicator that you might be unwell. Once the water has been removed, all we are left with is waste. We have a name for this waste, which most people find rude to say, but it's just a medical term. And of course, I'm talking about poo. Now people get embarrassed when talking about it, but everybody poos. You poo, your friends poo, your parents poo, your teachers poo, the Queen poos, and even your favourite pop star poos. Put simply, if you couldn't poo, then I would recommend seeing a doctor. And speaking of doctors, they can learn a lot about your health from the quality of your poo. In 1997, some doctors got together to create a ranking system for your poo, called the Bristol Stool Chart. And here it is. Type 1 is separate hard lumps, like nuts, which are hard to pass. Type 2 is sausage shaped but lumpy. Type 3 is like a sausage but with cracks on its surface. Type 4, like a sausage or snake, smooth and soft. Type 5, soft blobs, clear-cut edges which are passed easily. Type 6, floppy pieces with ragged edges, a mushy stool. And finally Type 7, which is watery, no solid pieces, entirely liquid. Type 1 happens when your large intestine absorbs too much water, and is known by a term you may have heard of before, called constipation. Whereas Type 7 is when your large intestine absorbs too little water, which results in diarrhea. Ultimately, you're looking for a Type 3 or Type 4 to show that you are keeping healthy. Of course, everyone's body is slightly different, but each one contains trillions of cells that take in our nutrients from our food and convert them into energy. And these cells also contain our DNA, which is the instructions for life. DNA stands for deoxyribonucleic acid and is made up of 4 bases: adenine, guanine, cytosine and thymine. Adenine and thymine pair together, and guanine and cytosine pair together, each placed in a specific pattern in a twisted ladder shape called a double helix. DNA is incredibly small, so much so that if you take the DNA out of just one cell and stretch it out, it would reach 2 meters in length. And if you take all of the DNA in your body and stretch it out, it would reach to the moon and back, not once, not twice, but 3,000 times. You share 99.9% of your DNA with everyone else, with that other 0.1% determining your race, if you have black or blonde hair, if you are biologically male or female, if you have blue or brown eyes, and even if you have dimples. You get 50% of your DNA from your mum and 50% from your dad. The closest you can get to someone sharing 100% DNA with somebody else is if you are an identical twin, though there are still some very small differences. It's not just people that we share DNA with though. We share 96% with gorillas, 90% with cats, 60% with chickens, and 50% of our DNA is shared with a banana.